Everybody, I'm Sal Furino. I'm a Customer Reliability Engineer. You can find me at sfurino on most social sites. My pronouns are he, him, and I'm here to talk to you about 9 things you should do when you're starting to use SLOs. So first off, show of hands, who has read the SRE book? Okay, a couple, all right. Who's read the SRE workbook? All right, a little fewer. And who's read the SLO book? All right, that's fine. I can work with this. It's all right. We could have a meaningful conversation here. So I believe each of these SRE books are directionally correct, but how to achieve SRE is still pretty much an exercise left for the reader. So what I mean by this is the SRE books were originally written by Google for Google. And newsflash, not everyone has Google-sized shaped problems. So after reading these books, the few of you that rose your hands, did you exactly know what to do? Did you actually have a meaningful way of how to implement each of those different items there that were discussed? So the general answer is no, folks generally don't. They generally try to chart their own adventure or build their own SRE path. They take bits and pieces of knowledge that resonate with them and they try to implement it themselves with mixed success. So I'm going to focus on a small subset of that information that's covered in these books, and that's SLOs. So SLOs are hard to get right. There's so much literature out there describing already, what SLOs are and how to calculate them. However, how to incubate SRE and observability culture can still be challenging and still an exercise pretty much left up to the reader. Additional guidance is often needed on how to coach organizations on how to use SLOs effectively. With SLOs, there's something I'm really passionate about. I feel that they can really empower conversations, enhance understanding of a mental model of a service, and what actions you need to take towards its reliability. There's even sometimes a song and dance some people try to tell you and saying, hey, SLOs aren't a culture change, but they truly are. It's a change in adopting a more data-based decision-making process across your organization towards your reliability. So too far. So as a customer reliability engineer, I've witnessed many organizations encountering stumble blocks while attempting to implement SLOs. And here I'm going to talk to you about 9 common issues that people generally encounter when they're attempting to implement SLOs. And the SLOs you do implement, how can you get the most bang for your buck out of them? So in the reliability world, we all love 9s. But I'm going to break these up into 3 groups of 3. We're going to have understanding systems, understanding expectations of systems behavior, and recognizing when a system doesn't match those expectations. So for understanding systems, if you don't understand a system, how can you measure it effectively? So a lot of what understanding the systems is about is drawing out the details of a service. How can you unpack some of the assumptions that you have about it? Hopefully these tips can give you some better understanding of your services. And at the end of the section, the goal is to have a well understood and high quality signal that you use to make decisions upon. So SLOs are a way to shine a light on what really matters to users. When engineers start doing SLOs, they generally gravitate to metrics they already know: CPU utilization, disk I/O, bandwidth. While these signals are usually good for scaling or trying to figure out if a service is bottlenecked, generally folks should try to pick higher value signals for targeting user journeys and more meaningful interactions across that service. Here I'm going to introduce an example of a service architecture and briefly talk through a collection of services that contribute towards a larger user journey. So Fortress Bank, names have been changed to protect the unreliable. They're in the finance industry. They're a card processor. What's their motivation for reliability? They have contractual and regulatory agreements in place in which they have to ensure that reliable payments are made from person to person quickly. This sounds pretty reasonable for someone who processes a bunch of credit card transactions. So let's try to discover some additional information here. What's the journey? As a user, I want to send money quickly to a third party. Hey, who hasn't sent money to a friend or somebody else here? Expectation: I should receive a notification that the payment is being processed. kind of reasonable. Hey, I'm sending the money to somebody. I want to know if it's actually being sent, or if it's starting to be processed or being initiated. Dependencies, a third-party application gateway, a clearinghouse screening. I get it. We can't send money to certain, people that might be on certain watch lists and so forth. We also need to make sure that we're actually sending money correctly to the right people and the funds are there. This all seems pretty reasonable for the journey here. So this is the service architecture diagram when I first met with Fortress Bank. It's a bit busy, but who in the engineering world hasn't seen a service architecture diagram like this, with a flow chart with a bunch of arrows pointing here or there, different things that might or might not be happening there. You can see it's clearly composed of several services talking to each other. And after some discussion, it took about a month or two of meeting with them weekly in order to dive more down into, hey, what are the actual journeys in these collection of services that you're responsible for? What's really customer user impacting here? It was identified we needed to bifurcate this whole thing into two distinct journeys. And we could even not measure some services entirely because they weren't the priority here. So this is the first journey we found, and this was because of an SLA that they actually had in with an actual customer here. This was the level 1 acknowledgement. Hey, we received your request to send money to somebody. We need to send that out to you via push notification or something here. The SLA for this was 99.9% of the time, acknowledgement of the payment had to be sent and processed within 2,000 milliseconds. Pretty quick. So we mapped up the flow of everything that was just tied to that SLA, and we kind of put it out here. Oh, hey, 1, 2, 3, 4, 5, 6, stop. Oh, hey, when are we starting our stopwatch? When are we ending it? And trying to get an idea of, hey, what's in scope here? Then we did the same thing for the level 2 acknowledgement. The level 2 acknowledgement was, oh, hey, we had to, I think it was 99% of the time, we had to process that, hey, the payment has been completed within 30 minutes. So, and these were all the different services there. You could see, oh, hey, just acknowledgement that we've received it is different versus actually going off to an external dependency, such as the clearinghouse or something like that, could take much longer for them to actually complete that. So these seem both of these seem pretty reasonable. Let's move forward a bit here. So next up I want to talk about is measuring success rates. Many organizations measure error rates instead of success rates. And while it's true, error rates are sometimes easier for organizations to grasp, and it's also true that they have limited scope. They only let you know of undesired outcomes you're already aware of. Versus if you just defined what is generally good behavior, leave everything else be uncertain. So let's flip this back to the previous example and walk through what that actually means for success rates along that journey. So here we have each of our different components, as we mentioned before in the level 1 acknowledgement. What does it mean for each of these to be successful? It's successful when we have 2, 3, and 400 HTTP status codes measured at the load balancer across these services. One that's actually being put in place. Now we know, oh, hey, this is what success looks like. This is important because sometimes for some of your services, hey, maybe some 400s are valid and are not successful behavior. It all depends on how you have it architected and how you wrote the code there. So it's really important to instead just define what is success, let everything else fall by the wayside and be uncertain. So next tip here, provide raw data for your SLOs. Many folks pre-aggregate their data from the data source, average, percentiles, sum. And while this is in the right spirit of picking the correct objective, it still hampers any additional insights you might have around that service. It gets more complicated when data sources themselves start downsampling that data and metric values, which can contribute to forward error here as you're starting to measure your reliability. So let's take a look at an SLO when it was pre-aggregated and it hid some information. And once we remove that, the team gains a meaningful insight there. So this next example here is with StreamsRS. They're in the entertainment industry. They do streaming video. What motivations they have? Contractual and competitive requirements. Who isn't doing streaming video nowadays? Goal, ensure low latency in streaming video to consumers. Makes sense here. So after spending some time with them, discovering, designing, and implement various SLOs, this is about 3 or 4 months, we started actually reviewing them. Hey, this SLO was clearly underperforming, their target here. Like, look how much they're burning budget there. However, looking slowly at this SLI chart, we were able to diagnose an issue that was contributing to their reliability. So I'm going to take a moment, and since we have a small group here, try to take a moment and try to take a look at the chart and see if you can try to figure out what was happening here. All right. So every 24 hours, there was a spike in latency that lasted about 30 to 40 minutes. This was their cache refreshing. After working with them for all this time, the cache was not a single dependency that they had listed out there, that for them actually refreshing it, but it had a clear impact on their user experience for a 30 to 40 minute window every day. And while this wasn't the only factor that was it, but this is definitely some low-hanging fruit they could try to figure out and refactor around so they could try to give their customers a better user experience around that time of the day. So, the big takeaway here is when you review your SLOs, you could sometimes gain additional insights to your reliability and dependencies you didn't even know were affecting your services. So, understanding expectation system behavior. We have a good idea of we're measuring the right things now. Hey, where can we dive in further to figure out what are some proper objectives, actions, and time windows for each of our SLOs? So you need to look back to look forward. Picking an objective can be hard, but for existing services, it's generally a good idea to look back to figure out where you should be going forward. It's generally misstep to say all our services need 5 nines reliability or better, without having the data or the business justification to back that up. So when it comes time to picking an objective, it's important to understand several factors. How reliable does my service need to be competitive? How much are we willing to spend to achieve those goals? When you analyze the previous performance benchmarks you have there, you need to understand your reliability targets and what are actually obtainable and not. Do we really need 5 nines if no one complained after an incident? And speaking of incidents, it's a good time to review your SLOs after them as well. If you have a bunch of SLOs for a service and it didn't burn budget after a major incident, you need to go back and gut check yourself. Are we measuring the right things here? It's also important to evaluate how much excess error budget you have. What's left to, let's say you don't have an incident, but hey, just day-to-day operations. Can we ship out a bunch of new features and maybe potentially burn some budget? Or hey, maybe we should start running some chaos experiments to actually try to improve our reliability going forward. So with that, let's get back to our friends over at Fortress Bank. So due to some contractual obligations, we have our upper bound set here of 3 nines. We need to have that acknowledgement of the service within 2,000 milliseconds. Great. Let's go back, and when we actually went back to look at the data, oh, hey, what's the P50 look like? Let's just try to figure out a rough idea of where we are. And it turned out to be lightning quick 100 milliseconds. 50% of the time, we're able to go off and return that really quick. Great. What does our P90, P95, and P99 look like? Let's figure out some round numbers around there, and let's try to step ourselves up towards that. And while we're there, let's also put some more, let's call it product-friendly labels around them. Oh, hey, P50, 100 milliseconds, lightning quick. 1,000 milliseconds, service is doing okay. We're humming along here. Maybe at 1,500, it's starting to lag. 1,700, oh, hey, something's wrong here. So sometimes it's useful to have these indicators, especially when you're in an incident or working with people that generally don't know the difference between 500 and 1,500 milliseconds. And what that means to architect that from an engineering perspective is sometimes useful to have these little monikers or friendly names there for other people. So we could follow, and we could also follow, we did the same thing over here for the level 2 acknowledgement. So I want to call out one more thing here. When we actually started to go back through the data, we found yet another new dependency here, the external API gateway. Apparently for this level 2 acknowledgement, it was going out a completely different endpoint back to the user than the level 1. And it wasn't until we actually went back to the data to see, oh, hey, what's actually being touched this, to actually figure out where our stopwatch is, or we're starting and stopping our stopwatch, they actually found that. So sometimes when you're going back and looking at the data and actually trying to calculate it, you start unpacking more of these assumptions that you had about it. So next up, observability without action is just storage. SLOs are living, breathing ideas. They shouldn't just be a bunch of things. You set it and forget it, or yet another dashboard for the sake of creating infinitely many dashboards. They're a method for codifying your service's reliability targets. And naturally, your runbooks should be tied to the observability-based solutions. I'd also recommend setting up automated actions to be taken, especially if you're trying to achieve 4 or 5 nines of reliability for your services. And you can also look at this from the other end as well. You also should only page or alert or take action when it's absolutely necessary. And we could talk about this a little bit when we flip back to Fortress Bank. So we have our objectives here. We have our standards. We got some nice labels there. Hey, let's actually go off and set some actions that correspond to these things. Oh, hey, when it's lightning, it's covered right now. But lightning, you can say, oh, hey, it's do nothing. Just move on here, ignore it. Oh, hey, we actually hit 1,000 milliseconds with a P90. Maybe let's send out a message to Slack to the team. Just let them know, oh, hey, some shit might be going down. Oh, am I allowed to curse? Okay, all right. Oh, geez. P95 at 1500. Hey, maybe we want to put in a service now ticket, or with a P99 at 1700, maybe we want to start paging on call. And if we start breaching our SLA, full on crisis mode, all hands on deck, fire off, get everyone here to start helping out. You could very easily also start tying these, once you start trusting these signals, into more automated solutions. Oh, hey, maybe we want to automatically roll back. Maybe we want to do some exponential back off or something else here. So with that in mind, I also want to mention that, for your SLOs, they have different audiences and there's different personas that go along with that. SLOs aren't only for operations and SREs. Different personas or groups take different actions towards reliability, and we need to recognize that as engineers. Some other groups might call them KPIs that might have different polling intervals, but overall, they're trying to still make database decisions. And it's important to consider introducing SLOs that all have the same SLI, but we have different time windows for these different audiences. So SREs and operational folks, they generally are concerned about the here and now. So what makes sense for them is probably 24 to 48-hour rolling windows. They need to take action immediately if the service is being unreliable. Maybe rollback, exponential back off, failover, internal rate limiting, maybe disabling costly non-essential services. Next we have our development team. They generally want something in the 14 days, rolling 2-week, maybe a calendar aligned window, something that generally aligns with their sprints. They want to use SLOs to help make better decisions, to focus on, do I want to ship bugs? Do I want to ship new features or fix some bugs? Hopefully you're not shipping too many bugs. And then your architecture and leadership teams, they generally like to review services on a monthly or quarterly time window. And they tend to make more structural changes towards reliability. They need to consider things such as, do we need to be deployed in another region? Should we maybe set up some automated smart retries? Would it be maybe more reliable if we used XYZ technology instead? Or maybe have an uncomfortable conversation with a third-party vendor about how they've contributed towards your unreliability. So with that in mind, these different personas, I like to give this resource out to a bunch of different folks, r9y.dev. I don't have a lot of time to talk about it here today because I'm short on time, but I highly recommend you either check this out yourself or come by afterwards and come talk to me about it. How it generally works is that there's a couple of different swim lanes here. At the top, you have your development, then infra, operations, observability, and then people. And the idea is, oh, hey, there's different nines here. 1 9, 2 9, 3 9s, 4 9s, 5, etc. And the whole idea is you do check off, oh, hey, what are all the different things I'm doing towards my reliability? And you kind of get like a wavefront here after you do that inventory for a service. And you go off and say, oh, hey, where are we lacking? What do we need to improve in order to get to our reliability goals and what we're doing? I will say this chart is a little bit opinionative of what you need to do to get certain nines reliability, but I think it's generally directionally correct of different things you need to look at. And when I've used this with organizations, most folks are generally like very top heavy. They're very far out there, but then they're generally lacking in the operational or observability or on the people end of things in terms of the culture of operating a social technical system. So it's really a great resource there. Please check it out. So recognizing when a system doesn't meet your expectations. We have the right signals. We have some good objectives. We have some actions that correspond to time windows. What else could there be? How we process those signals, how we document them, review them, and learn more in the process. So you need to enrich your dashboards with context. Dashboards need to be more than just a bunch of squiggly lines and bright colors. They need to give proper context towards the state of reliability. Show of hands, who's ever inherited a service from another team? Who's gotten a dashboard with that service when they inherited it? Who's inherited several dashboards for that service once they inherited it as well? It's sometimes hard to figure out what is good information and what is not. What can we make decisions upon or not there? So generally, first off, naming, adaptive taxonomy that you already have in your organization. If you can't, a good barometer here is if you can't understand what the alert or page is at 3 a.m. when you're woken up in the middle of the night, it's probably not named appropriately. Try to find something better there. Next, annotations. You should annotate your charts for your deployments, the start or the end of an incident, when objectives or parts of your SLO were changed, when you took actions for those services. Hey, we started auto scaling at this timestamp, or we did rollback at this one, or back off here. These come in so handy to when you're doing an incident review or doing a service review as well of what actions you took to defend your service's reliability. Next up, badges. You need badges for when your SLOs are at risk. Think large amount of burn rate, but more importantly, when it was last reviewed and affirmed to be correct and true, that we're assuming it here. Think back to inheriting that service you got with those dashboards. Who knew when's the last time someone touched it? 3 years ago? Is this even still accurate? Giving me good information here that the service is healthy. And then you also have dependency mapping. If a service is having issues, I need to look not just up and down, but I need to look around as well. What other services could be affected. Maybe we should automatically annotate our sister services or adjacencies in our different teams here when they're having an issue, because there's more likely to be fallback onto our service as well. You need to also think, who is depending upon this team? Are we supporting them well? Or who does this team depend on? Are we supporting them well as well? So next, document your SLOs. Engineers love documentation. How often when you inherited a service or looked at one for an adjacent team, have you asked yourself, what is this service? Who's responsible for it? Where is it even deployed? How do I fix it? Why are these metrics even important? When you're creating SLOs, it's important to document the who, what, when, where, how, why for an SLO's existence. And ideally, these should be documented in Markdown and bonus points if they're tracked in version control with your code along with your SLO definitions. And with that, with that in mind, myself and several others created the service level objective development lifecycle. I know it's a mouthful, the SLO DLC for short. It's a repeatable methodology for creating metrics that matter for service-centric organizations. And what's great about it is that there's a bunch of templates that are available in Markdown. You could store alongside your SLO-based definitions and have versions as well. So as you're changing and updating them, you can update your metrics as well to what we're affirming is correct and reliable. And last tip here, your problems aren't unique. Don't operate in a silo. If you're having issues incubating or evangelizing at your SRE or observability culture, remember that you aren't alone. There are several open standards and frameworks out there to help you and assist you, and several communities of practice that you could join to help out as well. And when I personally feel when we all come together and share our knowledge and experience, we can create a better internet for everybody together. And here I have a whole bunch of different open standards and stuff. For open standards, obviously open telemetry, open SLO, framework, store, R9 Wide Dev, Slow DLC, communities, the LFI community, learning from incidents, is done some remarkable work. And Google's Art of SLOs also has very helpful for organizations getting going with focusing on reliability. There's also several Slacks available, DevOps Days, SREcon, HangOps, Ryan's Leadership, reliability.org. Several socials, of course, the subreddits, SRE, DevOps, Tech Twitter, maybe I should edit the slide. Twitter, Tech X. I don't know if it's still a thing. I don't know. Mastodon, Blue Sky. These are all new communities of practice out there to get people start talking and sharing your experiences with reliability. And with that, I want to say thank you, everybody. You've been a wonderful audience. If you'd like to chat, feel free to find me. I'm also open for a Q&A. The QR code on the right is a talk I gave with Google's Steve McGee about different communities of practice around the reliability world. So feel free to check out that video as well from SLOconf if you want to learn more about communities of practice there for reliability. And with that, thank you, Q&A. Sorry, I said thank you twice. That's awkward.
Any questions?
Dmitry, so your metric system, how is it good for identifying metrics where we are kind of, good enough? Like we have like 5 nines and we actually need 3 nines at this point, right? So can it identify systems, where situation changed over time?
So the service is more reliable than it needs to be?
Yes.
Oh, that's a wonderful position to be. You have budget to spend. Oh, hey, maybe start looking into some chaos experiments. Hey, let's actually start burning more budget in a proactive and safe way. Oh, hey, let's start shipping out a bunch more features here, potentially trying to blow it up. Of course, you have automated controls to start defending that as well. Hey, maybe, I'm sure that's something your FinOps team would probably love to hear as well. Hey, maybe you start scaling back some instances, or maybe be deployed in, N-1 regions or something like that. That's... budgets are meant to be spent, and there's tons of different actions and stuff you could take there towards actually spending that budget there.
So do you think business should be involved here? Like, basically they should give some sort of inputs, to changes?
I'm going to answer that, but I'm going to walk around it for just a second. So I personally believe SLOs are meant for 3 different groups of people. First, engineers, people who are developing and taking action towards its reliability. The second is the customer, which is generally represented by a product org. And then the third is the business. How profitable does it need to be? So this is where, I kind of alluded to that a little bit with these questions where, hey, what are the goals for the service? What do we need in order to make it happen? And how, and is it not going to cost us too much? So I think the business should be involved, but it depends on how you break up the business. Like, is product part of that or not? I definitely feel the customer should have a say in the different features and things there to be shipped that are important.
Yep. Thank you.
But at the end of the day, business is writing the checks, so they should have a say. But yeah.
Other questions? Awesome. Thank you.